Hello students, in this video I'm going to be talking about parallel and perpendicular graphs. The previous video, Unit 3, Lesson 4, was talking about the equations of these lines. Now we're going to be talking about specifically what the graphs look like, and some of the hallmarks of these graphs include parallel lines being parallel to each other. In other words, they run alongside each other, same slope, never intersect, and perpendicular lines are going to intersect at a right angle. The learning target for today is talking about identifying and differentiating between parallel and perpendicular lines. The previous lesson was talking about analyzing their equations. Now we're going to be analyzing their graphs. There's going to be a lot more graphing, which is a basic skill that you learned in algebra. Here's the do now. It asks us to graph the line represented by y equals x plus 4, and then graph a parallel line to y equals x plus 4, which passes through this particular point. Let's do the first part first, part A, which is just graphing a line which is y equals x plus 4. Just by inspecting the equation, y equals x plus 4, I can tell that the slope is equal to 1, the coefficient of x, or in other words, the number that you could place here, multiplying by x is just 1, and the y-intercept is 4 because the constant term in y equals mx plus b is 4, which means I'm going to start at the y-intercept of 4, 1, 2, 3, 4 on the y-axis, and I'm going to be increasing by 1, which means up by 1 and over by 1. So I'm going to go up and over 1, up and over 1, up and over 1, etc. I'm actually going to extend it the other way because, as you know, a line is going to extend infinitely in both directions. So here we go. And of course, your algebra teacher would throw a fit if you didn't label the line that you drew, so here it is. So here's the first part. For the second part, it asks us to draw the graph of a line which is parallel to this line. Parallel meaning it has the same slope, and it also must pass through the point -3, 5. So now we have a couple of pieces of information. We know it has to be parallel to the previous line, which means it has to have the same exact slope, and it must pass through -3, 5. So let's first plot the point -3, 5. So backwards by 3, and 1, 2, 3, 4, 5 up. Here's the point in question. If it's parallel, that means it has to run alongside this y equals x plus 4 without ever intersecting it at the same slope. So what I'm going to do is I'm just going to start here at that point, and I know the slope is 1, which means 1 over 1, which means I go up 1 and over 1 every time I need to go to the next point, which looks sort of like this. And I'm going to extend it backwards in the other direction, just to show that it continuously runs alongside of that other equation without ever intersecting it. Now, just by looking at this, I can tell that the slope is 1, and the y-intercept is actually 1, 2, 3, 4 above the other y-intercept. So if this is y equals x plus 4, this must be y equals x plus 8. And that actually answers question C, right, the equation of the line from part B. So what we need to do in this lesson is make sure that we understand, first of all, what parallel and perpendicular actually mean as terms. Second of all, how they can be applied to a problem that's given to us. In this problem, we were given some information, the slope and the y-intercept of the first equation, and then we were able to figure out something about the second equation by just the information that was given. So we did a pretty good job, I would say. Nice work, us. Here's a quick review of parallel and perpendicular lines. If you are totally unsure about what these two things are, go back and watch the lesson, which is Unit 3, Lesson 4. But hopefully you remember that because you probably already watched that video, probably yesterday. And no mystery here, two coplanar lines, coplanar means they're on the same plane, that do not intersect, and they share the same slope. These two lines have the same slope, so do these, and so do these. For perpendicular lines, it's a little bit different. They are not two lines that keep on going next to each other. They're actually lines that intersect. And as you can see in both of these diagrams, they intersect at a right angle. They meet at a right angle. They actually form 1, 2, 3, 4 right angles. And they have negative reciprocal slopes, which we talked about in the previous lesson, means that we take the fraction of the slope for one of the equations and we flip it upside down and change its sign in order to get its negative reciprocal. Remember, negative means change sign. Reciprocal means flip it upside down. Moving right along. In this guided activity, it asks us to graph the following 3 lines and asks us to identify some similarities and differences between each line. So all of these lines have a 2 as their slope. I want you to notice that right away. And they have different y-intercepts. This y-intercept is 0 because there's no constant term. This y-intercept is -3, and this y-intercept is 4. Let's take a look at what these lines look like. All right, here they are in all of their parallel glory. You can tell that all of these lines are parallel because they have the same slope. and I labeled all of the lines. This is y equals 2x plus 4, this is y equals 2x, and this is y equals 2x minus 3. You can tell by their y-intercepts what their equations are going to look like. It asks now what the similarities and differences are between each line. Let's be sure to identify at least one similarity and one difference between each line, and the conclusion that we can draw about their relationship, we might have spoken about it already in this video. Alright, the similarities are that each line is straight. You can tell it's a straight line, it's got a constant slope, and each of them has the same slope, the 2, the 2, and the 2. The main difference is that each line intersects the y-axis at different points, here at positive 4, here at 0, and here at negative 3. Which means, since they have the same slope and different y-intercepts, we can refer to these lines as parallel. The next part asks us to graph the line y equals negative 1/2 x. Let's do that now. And here's that graph of y equals negative 1/2 x. You should see that it also has the same y-intercept as y equals 2x because both of them have no constant term, which means their y-intercept is 0. The slope is different though. This is negative 1/2 x, which means from the y-intercept I'm going to go down 1 and over 2, down 1 and over 2, etc. What's the relationship between this line and the lines from parts A, B, and C? Well, let's prove something about the slopes first. So here's one thing that you could notice. This negative 1 over 2, which is the slope of the purple line, is the negative reciprocal of 2 over 1, which is the slope of the red line, and also the green line, and also the blue line. Which means, since they are negative reciprocals, we can tell that these lines are perpendicular. And there's my conclusion. I can say definitively that if I can identify negative reciprocal slopes, these are negative reciprocal slopes, that means that the lines are perpendicular. And also, if I can identify identical slopes, like all of these slopes are 2, that means the lines are parallel. That's the basic idea behind this premise. For the check for understanding, we're going to do this together, and then the problem set questions we're going to be doing in class. For the graph of this given line, we're supposed to identify its equation first, then write the equation of the parallel line, then graph the parallel line. Now I need only 2 pieces of information in order to write out an equation, and it is the following. All I need is the slope and the y-intercept. In this case, the slope is, well, let's say I went upwards by 1, and I went over by 6. So that means my rise is 1, and my run is 6, making my slope up 1 over 6, or just 1/6. The next thing I need is my y-intercept, and I can tell the y-intercept is going to be here. It is a point that is where the line crosses the y-axis. Unfortunately, it doesn't land on any of the exact boxes, but we could figure out this exact point using a method that you learned about a little while ago. And that method is the midpoint formula. I know that this point and this point have a midpoint, and that midpoint is where this line crosses the y-axis. So in order to find out that exact value, I'll use the formula. Here are my first point and second point respectively, negative 3, negative 4, and positive 3, negative 3. You substitute those values into the midpoint formula and get an answer, which is 0, negative 7 over 2. This is a little unwieldy as a fraction, so I'm going to turn it into a decimal, negative 3.5. And you might be saying, wait, I'm allowed to use decimals in my answer for linear equations? The answer is yes, decimals are people too. I know now that the y-intercept is equal to negative 3.5, so I'm able to substitute that 1/6 and that 3.5 into my equation. The next part of the question asks us to write the equation of a parallel line. Well, we're in luck because all that parallel line needs to have is a slope that's the same as the slope that was given here, this slope of 1 over 6, which means I can choose any old thing for my y-intercept as long as it's not exactly the same as negative 3.5. I'm not going to choose any numbers that are too crazy because I can see that my y-axis only goes up to 5 and negative 5 respectively. So let's use 4. So I've identified that the parallel line, or my parallel line that I'm going to be using, is y equals 1/6 x, which is the same slope as this 1/6, plus 4. Different y-intercepts, we're doing good. So y equals 1/6 x plus 4, I'm going to start at 4, and I'm supposed to go up 1 and over 6. So from here, I'm supposed to go up 1 and over 1, 2, 3, 4, 5. I'm just going to approximate it a little bit because we can't get exact here. And then I'm going to do the same thing backwards. I'm just going to keep it running this same direction. How about that? Amazing. Last thing I need is a label, so I'm going to label it with this equation, and that finishes my problem. One thing that we can just check to make sure about is it's supposed to be a parallel line, which means the slopes are supposed to be equivalent, and they're supposed to be running alongside each other, never intersecting. These two lines don't look like they're going to intersect anytime soon, so we're good to go with that. For the graph of this line, we're supposed to identify its equation, write the equation of a perpendicular line. Ooh, careful, they gave us a little curveball there. This one is supposed to be perpendicular, and then graph that perpendicular line. This line, we can easily figure out its slope by using that counting method. So I'm going downwards by 1, 2, 3, and over by 2. That means my slope is down 3 over 2. That's negative 3/2. Now we could turn this into a decimal. We could turn it into negative 1.5. However, slope is the part of the linear equation that you should always keep as a fraction. The reason we try to keep slope as a fraction wherever possible is because the slope can be interpreted as rise over run, and it's very convenient to keep that slope as a fraction and not change it into a decimal. It wouldn't be wrong, it's just not the best way to use slope. It would be kind of like putting your socks on over your shoes, because technically the socks are supposed to go on your feet, but that's just not how usually people do it. If we're supposed to continue writing the equation of this particular line, this blue line, we also need to find the y-intercept, and we can easily find the y-intercept by just identifying where it touches the y-axis. That point is at negative 2. So now that we have the slope and we have the y-intercept, we're able to easily find the linear equation for this line. M is equal to negative 3/2, and B is equal to negative 2. So there's our line, and there's our equation. All right, the next part asks us to write the equation of any line that is perpendicular to this line. Well, the nice thing about this is all we need is a line that has a negative reciprocal slope to this slope. We actually could even use a line that has the same y-intercept, because keep in mind, for parallel lines, they're not allowed to intersect. For perpendicular lines, they must intersect. So my general procedure, my little secret trick, is whenever it asks for a perpendicular line and it doesn't say where it has to go through, I usually just use the same y-intercept. Why not? All right, so now I need to change this negative 3/2 slope into a perpendicular slope, which means I need negative reciprocals. So I'll take my given slope, which is negative 3/2, and I'll turn it into its negative reciprocal by doing two things. I'll change the sign from negative to positive, and I'll change the order or orientation of the numerator and the denominator backwards. So my 3 goes to the bottom, my 2 goes to the top. This makes a negative reciprocal slope, which means this slope represents a line that is perpendicular to this slope's line. Now all I have to do is append a y-intercept to this and graph it, and I'm all done. All right, so I've written my perpendicular line, which is y equals 2/3. I got the 2/3 from here. X minus 2. Remember, this minus 2 didn't have to be that. It could have been literally any number that you wanted. The only reason I chose negative 2 is because it happened to be the y-intercept of the previous line. So now I'm going to graph it by starting at negative 2, and I'm supposed to be going up 2 over 3. So up 2 over 3, up 2 over 3. Well, I can't make that over 3, but you get the idea. And then I'm going to extend it backwards in a straight line, and you can see that it also intersects down to over the other way 3. There is my line. Let's label it as y equals 2/3 x minus 2, and let's just verify that these two should be perpendicular. I have a negative 3 over 2 here, I have a positive 2 over 3 here. They are negative reciprocals, which means that these two lines must be perpendicular. Fantastic. All right, this lesson we went over the idea behind parallel and perpendicular graphs. I know that the way that we ensure that two lines are going to be parallel is if they run alongside each other and never intersect. And the way that we ensure that two lines are perpendicular is if they intersect each other at a right angle, making negative reciprocal slopes along the way. All right, folks, good luck studying.